Implicit differentiation now is for finding slopes of tangent lines that are not functions in the traditional sense, meaning that it would fail the vertical line test. So it would have a function value at two different points for x. Say like the circle. It's not a function traditionally. So we can write that as x squared plus y squared is equal to 1. Solving for y, and then taking the square root, plus or minus. Now we could take the derivative of this, and it would involve the chain rule. But y prime would basically be minus x over plus or minus the square root of 1 minus x squared. And because we said that y is equal to the square root of that, we could say minus y over x. This is a very, very simple case. We can also implicitly differentiate x squared plus y squared is equal to 1. And what that means is we just differentiate. Remember, y is a function of x here. We're just differentiating the entire thing. That turns to 2x plus 2y dy be dx. And then we can subtract the 2x and then divide by the 2y minus x over y. And as we can see, this gives us the same result. If we want to find the slope of the tangent line to the circle, we have to first choose a point. So we can do x is equal to 1/2, y is equal to root 3 over 2. 1/2 squared plus root 3 over 2 squared. Is that equal to 1? Well, that's 1/4 plus 3 over 4. That is equal to 1. That's really ugly 4. So we found that dy dx is equal to negative x over y. And we can plug in our values. Minus 1/2 over root 3 over 4, 2. Sorry. And that's 1/2 divided by root 3 over 2. And we can turn that into a multiplication of the reciprocal. Minus 1 over root 3, and we don't like it like that, so we multiply by 1. And that's our slope at that point. Now our line now sorry, I made a mistake. That's a plus 1/2. After doing some manipulation, we have to combine root 3 over 2 with the root 3 over 6. And to do that, we multiply that by 1, or 3 over 3. And that's 3 root 3 over 6. So that's 4 root 3 over 6. That should be a positive because that's not positive. That's not. And that's the slope at that point, 1/2 root 3 over 2. And that's the equation of the line through this point and its tangent to the circle. Sometimes expressions can be quite hard. Let's say we want to find the slope and tangent line through the point 1, 1. We can rewrite this as and then we can differentiate. Fix that y real quick. Since we have a product of x's and y's now, this is going to be like a product rule. Well, not like a product rule, it is a product rule. So the derivative of x squared y is equal to the derivative of x squared times y plus the derivative of y times x squared. And this is just 2xy plus x squared dy dx. For our second term, pretty similar process. But now we have y squared plus, and the derivative of y squared is 2y dy dx times x. And this becomes y squared plus 2xy dy dx. For our x squared y squared, we can say, we could pull that negative out and multiply by -1 later, but it would be the derivative of x squared times y squared plus x squared times the derivative. I guess this is a better way to look at it. X squared times the derivative, rather than putting the product on this side, we should put it on this side, times the derivative of y squared. This becomes 2x y squared plus x squared 2y dy dx. Two x y squared plus 2x squared y dy dx. And of course, because it's negative 2xy squared minus 2x squared y dy dx. We can write it into one equation, 2xy plus x squared dy dx plus y squared plus 2xy dy dx minus 2x y squared minus 2x squared y dy dx is equal to 0. And now we're going to solve for dy dx, and we can isolate them and factor them out. and put all the terms together with the dy dx. I'm just going to skip a couple steps, but it's just basic arithmetic at this point. Okay, so that's our dy dx is equal to this. Dy dx times some arbitrary numbers of x's and y's is equal to something else, and then just divide this out. And since we're looking at the point 1, 1, we can just plug 1. X is equal to 1, y is equal to 1 into this. So 2 times 1, oops, not y. Like that. That's 2 minus 1 minus 2 over 1 plus 2 minus 2. And this becomes minus 1 over 1, or just minus 1. And now y minus y1 is equal to n times x minus x1. Y minus 1 is equal to minus 1 times x minus 1. Y minus 1, y is equal to minus x. Minus 1 times minus 1 is plus 1, plus 2. Y is equal to minus x plus 2. This is our tangent line. And that's pretty much it. So we went from this function, x squared y plus y squared x is equal to x squared y squared plus 1. Feel free to plot this on Desmos. Just want this tiny little So we went from this function, this expression, I should say, and we found that at the point 1, 1, this is our tangent line. If we were to plot this, say on Desmos, and plot this also, we would see that it does indeed only pass at one point. Anyway, thanks for watching.